Now this contraption is the Induction Heater MK3, and we're going to try and melt 4 ounces of pure silver crystals. We'll just go over the machine first. We have 3 of these beautiful big transformers, which are really just to get the right voltage that I want. This will turn 250 volts into about 137, which goes into here, turning it into about 73, which goes into here, which turns it into about 38. Then goes into those rectifiers and the filter capacitor, producing 53, 54 volts DC. But that's with no load, right? No current yet, so it doesn't. It's going to drop a lot once the power goes on, which I will do now. This arrangement here is sort of a soft start, so I can just give it a bit of power first through that water-cooled resistor, and now we're drawing 7 odd amps, and then we bypass the resistor altogether to get full power. Obviously this has to be done electronically eventually, but for now. So now we're running at 10 amps. Focus on that. Take my word for it. No, sorry, 15 amps. 15 amps. And the voltage has dropped down to 40 volts with that load. Now this will start getting hot. To help it along, we're going to put this on top to insulate it. Actually, while that's cooking, we'll just go over the circuit a bit more. So yes, the AC 38 volts comes in there, rectified, filtered. This is woefully inadequate at 15 amps. This 4900 microfarads. I've got to put in a few more capacitors because the ripple will be awful. That 41 volts is probably wobbling up and down between 35 and 50 volts. It'd be terrible ripple voltage on there. Anyway, that goes through to the ZBS driver circuit, just a very basic circuit that's all over the internet. 2 transistors oscillating, pumping power into this tank circuit, which is a coil and bank of capacitors, and the magnetic field in the coil induces eddy currents in the metal immersed in it, or whatever conductor. In this case it's the graphite crucible, which is starting to glow. The silver itself is probably too good a conductor. It doesn't get enough eddy current to melt, so it's using the crucible to provide the heat, because that's graphite and it has a bit more resistance and gets hotter. Now everything on this thing gets hot. So we have a water cooling system, a reservoir of water with a submerged pump. So it's pumping water up here into this cooler module that tries to carry some heat out of the electronics, then pumps it through the coil and back out through the radiator with a fan behind it and back into the reservoir. Now you can see the water flow is pathetic. That's because the pipe here is too narrow, way too much resistance. I have bought some new pipe, and I've made a new capacitor tank circuit, which is this thing, 1/4 inch pipe, but it doesn't work quite so well. I've got to do a bit of investigation as to why that is. I think its resonant frequency is a bit low. And anyway, so the radiator's there. That's an 80mm fan, but I think once I get the full power, I want to get going inside this thing. And this is just a development test bed. I mean, this is all just sitting here ready to be jiggled around until I finally end up with a design that I can package up properly. But I've gone to a bit of trouble to set this stuff up fairly permanently, because that's not likely to change much. The thing I'm going to do is put on two 120mm fans, so that it can really work this radiator if it has to. And that's probably about it for now. Let's see how this is cooking. Yep, now on the camera there's just glow. I need an IR blocking filter. It's starting to melt. The can't be seen, but the, oh yeah, how about that? The silver is starting to drop. I've got a lot more that I've got to keep spooning in as it melts and drops down. When the crucible's nearly full, you get something like this, which is 5 ounces. Here I'm doing 4 because that was really pushing it, getting 5 to melt. Yeah, it's all gone now. So I'll just keep spooning in more silver crystals. And I think I'll put the phone away now because I need 2 hands to do this properly, and come back to the results. Here it is, all nice and molten. Probably can't see much, but it's very shiny. Silver's shiny to begin with, and molten silver is really shiny. It looks like it's almost like a clear liquid, and like you're looking through it to the bottom of the crucible, but you're actually just seeing the reflection off the interior of the crucible on the metal. Now I haven't got enough. I haven't got a mould that I can pour this into. You see how it's bubbling? That's convection currents, maybe oxygen coming out of the molten metal. So yes, I can't pour it. Last time I tried was with some lead, and I spilt it onto the coils, which caused a massive short circuit. Seeing sparks come blowing out of here. Disaster. So I'm going to turn this thing off before I try and get it out, and in any case I'm just going to let it cool in the crucible. I won't try pouring it. Here we are melting some more silver. I'm going to make 3 ounces of silver this time, 3 ounce ingot, and this is just getting to the point where the first part of it is molten. Too close for the camera really. And it just dropped in. Got to keep the camera away from it because it's so much radiated heat, but we'll risk it for a minute. You can just see the molten metal there. I've got to try to get some sort of a UV filter, so IR filter rather. Right, put some more material in there. Just don't want to keep the camera very close to this because it is so hot. And the very last of those crystals are just dissolving into the melt. I'll let it get nice and hot, then cool it down slowly and see if we can get a nice finish. Now here are the results of some of the melts I've done, some of the ones that were shown in the previous part of the video, and some others I've done since. This is a 1 ounce, those 3 are 2 ounces, 3 ounces, 4 ounces and 5 ounces, which was about the limit that I could fit inside that little crucible. With this, the power available to this, it was pushing to melt that. It couldn't go much bigger. And a bit of gold, it's got copper and silver in it as well. I tried to melt that and it just got hot, nowhere near melting, but the copper in it oxidized. Hopefully we'll get to power levels which enable that to melt properly. We'll just have one last look at this version of the induction heater because I'm about to replace the baseboard and put a few more components on and change the layout slightly. So this is the last time we'll see it like this. I think I didn't explain fully about this bridge rectifier that burned out. I don't think it was in the previous section. I had an accident where tipping out a crucible of molten lead shorted out those coils, causing a massive current flow, which one of these MOSFETs couldn't cope with and ejected a giant spark and blew itself to pieces. Then that fault came back further, burned out the bridge rectifier, or rather caused it to turn into a short circuit, which then short-circuited the transformer and burnt that out. So we had a catastrophe from arsehole to breakfast time. I didn't explain, I don't think either as well, this power supply here is just to produce 12 volts for the pump and fan. That'll eventually be replaced by something smaller, but not quite yet. The next version, and of course that transformer now being defunct, has been replaced by the big girls there, which just turn 250 volts down to 50 odd, and in the future I hope to bypass one or two of them for higher voltages and higher power. So that the next version of this will have some minor layout changes, a few more bits on there, mostly to make it a bit more civilized, because I'm doing a few crazy things like connecting wires manually, and this ugly thing, which is just a giant resistor nichrome wire wrapped around a wooden block held below water by a brick. I've got an improved version of that. So that's it for this version.